run the same job which we have seen earlier. I am changing the path again, and I'm running the job to get the card count. Okay, well, it will take just a minute. First, we will start with understanding the counters, and then we will play with them by passing certain parameters in runtime, and we will see the difference in the performance, and also we will interpret the information provided by the counters to determine which one is running better and all. And I will document all these things by Tuesday. So after Tuesday's class, in those 10 days, if you can try all these things and come back after the vacation, we can resume where we stop on Tuesday. So first, we completed, the job is completed successfully. First, review the input first. Input. So if you see the command, this is the syntax. You have to specify Hadoop jar to run a MapReduce job, and you have to give the jar file name. In this case, planning.jar, which I have compiled, or any developer will compile and pass on to you. And then we have even developers will give this command to you. Typically admins will not come up with this. They will give the command to you, and then you have to schedule it as using your enterprise scheduler to submit the job. Okay, typically both the code configuration and the data and the instructions will be provided by the developers. And this is the program name, Java class name, which you are trying to run to get the count. And then we are passing this input. The input is user SDUser logdeck.txt. It's a HDFS file. So to validate whether that HDFS file exists or not. So sometimes these jobs fail and you have to troubleshoot the issues. That will be admin's responsibility. So you should know all the commands in by heart when those issues pop up. So now first we are validating whether the file exists or not. File exists, and the owner is HD user, and the group is super group, and only owner have the right permissions in that location, who is HD user, and others cannot do that. And the output path is user HD user output cards count.03. And depending upon the program logic, sometimes it might delete the existing directory and create a new one, or it might add a new file within the directory. It can be controlled by the developers. Okay, sometimes it might fail, complaining that the directory already exists. Sometimes it might not fail. It all depends upon how developers develop their code. So by default, typically when you run the program on the same directory, it will fail, saying directory already exists. Okay, in those cases, either whenever you rerun, you have to give a unique ID to the directory name and then run the program, or developers need to take care of deleting the existing directory and recreating the new directory, or appending to the existing directory. So that all needs to be negotiated between developers and admins depending upon the requirement. Okay, so now earlier I gave 03 and it ran successfully. So what happens in that location? What happens? So what is this path actually? Okay, so first let us do Hadoop fs minus ls command. Hadoop fs minus ls command, and you can look at the path. This is the path. So when you give output, you typically give the directory name. You won't give the file name. Okay. And if you look at this directory name, there are two files under this. One is part of 0000 and the other one is part of 0001. Ideally, so there is something wrong in the program. So card count should only have one record. Okay. Let us forget about that. For now, when you run ls on this, it is nothing but a directory, and there are three files. One is a success file, which is just a marker file. It will always be of 0 size. If there is something wrong, there is nothing in this location. The directory will be empty. If it is successful, then there will be a marker file called _success in this location, and then there will be additional files which will have the data. Okay, and as you have seen here, there are two files. I will explain why there are two files in a moment. First, let us validate the output and see whether the output is correct or not. So Hadoop fs minus cat art star, and the output is not a card count. It is card count by suite. So these 4 are suites. It is card count by suite. So there is something wrong in the program. So if you look at this, we ran this card count program, and if you look at that, it says count only. Then why it is? Yeah. Okay. I think. Which one I ran? And training.demo.cards.card count. This is training.demo.cards.card count. Mapper is map.class. Okay, I know what is the problem. Here it is incorrect. Yeah. So yeah, there is a bug in the code. So by validating the output, you can say that the output is not as expected, and developers have to troubleshoot the issue and debug it and fix the code. So now I modified code, export, next. Finish. Yes. So now it will work. I'm not going to rerun again. So this is how the output will look like, and now we will determine why there are two files. Okay. So as you have seen the output, so we will start from the beginning. And at the beginning, it says number of splits are 17, and the number of splits are determined by the number of blocks of the file. We are talking about 2 GB file, which is largedeck.txt. As we have seen earlier, you can run HDFS fsck user hd user largedeck.txt files blocks. Okay, so there are 17 blocks, so it is using 17 splits. So number of splits are 17. So depending upon the number of splits, it will determine the number of mappers. So as you have seen, the job is run with 17 mappers. Then it will submit the job, and once the job is done, it will emit the counters. And you can look at the job counters, and it is saying launch map tags are 17. and launched reduce as equal to 2. Why it is using 2? Okay, first let us look at the program. And here we are talking about, even though we run card count program, it was using card count by suite. So you have to look at that program. And here, as part of the job configuration, it is configured, the number of reduced tasks is configured as 2. So MapReduce framework cannot determine how many reduced tasks should be run. It needs to be determined by developers, and he has to either do it programmatically, or he can actually do override it runtime. Okay, we will come back to that in a moment. Okay, let me do one more thing. Okay, let me comment out this one. Okay, and let us go through other details also. So we have seen that there are 17 blocks, and for each block there is a mapper created, and then depending upon the number of reducers specified in the program, it has used the number of reducers. So whether it is efficient or not, we will see. We will come back to that in a moment. And then if you look at the file system counters, it all talks about I/O, how much I/O is done. Okay, how many bytes have read, how many bytes have written from the file system and from the HDFS. As we are dealing with the HDFS, where this file is, we are reading file from HDFS. This is the main metric than the top one. Top one is the regular file reads. We are not reading much of regular files in this program. We are primarily reading from HDFS. That's why it says 2 GB, which is close to the size of the file in HDFS. Okay, and then number of bytes written equal to 61, because once the MapReduce is done, the output is written to HDFS, and we have only 4 entries in those. So it's pretty small, that size of data that is written to the HDFS. Okay, that is related to file system counters. Now coming back to job counters, apart from how many map tasks and how many reduce tasks are executed, it also tells how much time spent by mappers, map tasks, how many time spent by reducers, and also how much time spent by cores or CPUs, and how much time spent by I/O. At each mapper and reducer level, it will give you the details. Okay, you need not to worry much about these values. The only thing you need to do is, when you actually play with it, when you rerun, you have to compare these things and see whether it is going down or going up. Okay, and then MapReduce framework. So MapReduce framework will give how many input records are read. So there are 163 million cards in the 2 GB file. Just give me a minute, okay? Yeah, thank you. So I'm talking about map input records and the relationship between that and the map function invocations. As I mentioned earlier, 52 record on a data set of 52 records, the map function will be invoked 52 times. But now we have 163 million records, so that map function in my program will be invoked 163 million times. And then we are not filtering anything. So you can actually look at this information and troubleshoot many issues. So as our program does not require any filtering, number of input records from mappers and number of output records from mappers should match. Okay, and we will discuss about combiner later. And as I mentioned to you earlier, to get the card count, we have only one key, which is count. But this program accidentally, because of the bug in the code, instead of running card count, it has ran card count by suite. And there are 4 suites in the whole deck. So you can see reduce input groups as 4. If you run a correct card count program, reduce input group only will be 1. But here it is 4 because we have 4 suites. Okay, and then reduce output records are also 4, so that is correct. In this case, the reduce input records should either match the number of map output records or the number of combined output records. In this case, it is matching with combined output records, so we are good. So you can look into this information, understand this, and you can actually troubleshoot many of the issues. Okay, and at the higher level, file input format counters, we have read 2 GB of data, and we have written 61 bytes of data. So it is very, very, very important information. So the 2 things that you keep in mind when you want to troubleshoot the job is the job.xml file, which I have explained earlier when I am talking about classic, and the counters. Using this information, you should be able to troubleshoot many of the programmatic issues. Okay, and let me show you the job.xml information for Yarn. We have already seen for classic. Now we'll look at Yarn. So when you actually start navigating through the Resource Manager Web job in Resource Manager Web UI, you will come to this page when you click on the application master, and then you can click on configuration. Okay, it is already done. Let me go back. So now we think 504 8088, and here this job is already done, and you can see, you can go to history server, and here you can see a lot of details. You can click on overview, and it will give you the overview of the job, and then you can click on counters, and you can see the same information what you are seeing in the command prompt in the counters. And then you have to click on configuration, and this is what the XML file is for that job. So you have to be aware of this location to troubleshoot to any issues when it comes to debugging or troubleshooting MapReduce applications. And then it will map tasks will give you the details about all the map tasks, and reduce tasks will give you the details about the reduce tasks. And if you click on map tasks, and if you click on this individual map task, you can get into lots of the task by clicking on this, and you can see how the progress is happening. Okay, yeah, you can actually start going. If you are interested, you can actually start going through this, and it will start exploring what is going on behind the scenes. Then you will understand a lot more internals what is happening in the MapReduce applications. Okay. Now we have seen how the job is run by going to. So when I actually run the card count, we know that the output is just 1 record, but this is showing 4 records. It itself will tell that there is something wrong in the program. Okay. Now let me copy the fixed program and rerun it again.
Durga, this is Karte. Question, Durga.
Yeah, Karte, tell me.
Happening. Hey, I was just going over the video folder in the Google shared drive. I see only one, the one file in that drive, Durga.
I think you might be looking at the wrong location. Probably you might be looking at this. This is not the right one. The right one is there is a directory called Novising 2014 December at 12, and if you click on that, there are multiple directories under that. One is exercises, so all the exercises will be under this. All the PPTs will be under here. All the scripts will be here, and then all the videos are here.
Oh,
okay, and the VPN instructions are here. You can ignore these ones, this video, HDP, and the archive you can ignore. Okay, now the job is done. Still it is showing reduce output records as 4. So still I didn't run the program correctly. So what is going on? Okay, let me do this. Let me fix this one, card count by pip, and I'm saving it, and then export. Okay, now let me do this exit. So this one, try to get the count by pip. We have 13 pips, so there should be 13 records in the file. First one, I have already commented out the number of reduced tasks, and I will try to explain the rationale behind how to come up with the number of reduced tasks and how it can improve the performance in certain scenarios. So if you see, the number of reduced output records are 13, and we haven't specified any reducers as part of the program. We commented it out. So now let us see what is going on there. Okay, and this is the output path. And Hadoop FS LS. So there are 7 files created, and why there are 7 files created? So we will see why there are 7 files created. Okay, and you can actually troubleshoot the issue by going to the job track. But if you try to see the output, we got 13 records because there are 13 pip. We got 13 records because the program is card count by pip. Now let us see why there are 7 reducers. Okay, and first thing you need to do is you have to troubleshoot from job.xml file. Okay, and here you can click on about jobs, and then and this is the latest one which we ran. You can click on that, and you can click on configuration, and there is a parameter called map reduce dot why it is using 7 reducers. And they change in every version. This is the problem with these open source tools. It is not even there. Okay, let me do this. I know what is the problem. If you click on home, leave page, yarn, configuration, and if you map reduce dot, what? Okay. So for some reason it is not working. But yeah, the main thing what I want to show you is, yeah, you can troubleshoot the issue from the counters. And now I will show you how to change parameters at runtime and rerun these jobs. Okay, so there are multiple things which you can consider to run. And after the completion of the course, actually I am creating a playlist related to performance tuning, which covers both map, reduce, Hive, pig, etc. Almost all the Hadoop ecosystem tools. You can go to the playlist and you can acquaint with the performance tuning techniques, different techniques, and by going to the playlist. For now, I will just let you know how to pass certain parameters in runtime and how to play with the programs to complete fast if required, or to slow it down if required. Okay. In this case, one of the parameter is called split size. Okay, first let me explain what is split size, and then we will try to customize that split size at runtime, and we will see the difference in the behavior. Before getting that, remember that this program is run using 17 mappers because the file size is 2 GB plus, and the file is divided into 17 blocks. And by default, for each block, it had created one mapper. Okay, now we will see split size, and we will customize the split size at runtime and see how it will make the difference while executing the program. Okay, so before getting into that, let us understand the parameter names. You can click on configuration, and you can search for split. Or you can go here. Yeah. So this is the parameter. Okay. And by default it is 0. We will see what happens when it is 0 and what happens when it is more than 0. Okay. So let's say we have a 3-node cluster, or even larger cluster. Let's take the example of this one. We have a 5-node cluster, and we have 2 GB file, 17 blocks, replication factor 3, which means each one will have almost all the blocks. So yeah, there are 17 blocks, and as we have 15 of them, let's say 5, right? So let's say 1, 2, 3 have gone to this, and 4 to 5, 4 to 6 gone to here, and then 7 to 10 blocks gone to here, and then 11 to 14 gone to here, and then 15 to 17 gone to here. And then because of the replication factor, this 1, 2, 3 might be on other nodes as well. So what I'm trying to say is, this one might end up with 6 blocks of a given file, even though there are only 17 blocks because of the replication factor. Each node in this cluster might end up with 6 blocks of a file, and which means that it might have almost 750 MB of the deck of cards, which is 2 GB on each of the node in the cluster. So by default, the file will be divided into blocks based upon the block size, and by default mappers will be created based upon the number of the blocks of the file. So block size is the lowest granular where the file will be divided and stored in the HDFS. The counterpart for block size, which is a HDFS parameter, is a split size, and it's a map reduce parameter, and it's the lowest granularity at which file will be processed. Okay, so in this case, if we can club few of these blocks into one split, and if we can create one map process to process the data, then the usage of resources will go down considerably, and our cluster will can be shared across multiple jobs more efficiently, and even your jobs can run faster with lesser amount of resources, because you need not create 17 JVMs. Instead, you will be creating lesser than 6 or 7 depending upon the split size. So to run your programs efficiently on a larger files, you can play with split size, and you can reduce the number of process that needs to process the data by playing with the split size. Okay, block size is the lowest granularity at which file will be divided. So here, if the block size is 128 MB, it will create 17 blocks. with 128 MB each, and those 17 blocks will be distributed in the cluster. The counterpart of block size, which is a HDFS parameter, the counterpart of it in the MapReduce world is split size. And if you increase the split size instead of 128 MB to 256 MB in this cluster, you will be able to complete the job with 9 mappers rather than 17 mappers. So as you reduce the number of resources, if we all try to run the job now with fewer number of mappers, we all can share the cluster more efficiently, and even the jobs can run quicker fashion, because it need not create JVMs and clean up JVMs, as many JVMs with a lesser split size. Okay. Now let us demonstrate that, and you will understand. Earlier I have already ran without with the default things, and the split size is taken as 128 MB. Which is default as block size, and you can see that there are 17 splits to execute that card count. Now, I will run the same program, and here I am trying to pass I am trying to override the parameter at runtime. Okay, and the parameter name is this one. By default, it is 0. Now I am changing it to 256 MB, and I am running as 01. Now if you see number of splits are 9, and if you go to this if you go to this location, and if you try to monitor the job, you can see that it is only using 9 mappers. And you can click on this job, click on configuration, and you can search for split size. Here it is 256 MB. Okay. So if you think about it, what are the side effects of it? You are reducing the number of distributed processes. So in some cases, it might be beneficial to you. In some cases, it might not be beneficial to you. So if on average, if each of the node in the cluster has only one block of a given file. So for example, instead of 2 GB file, if you have only 256 MB of 256 MB file, which will end up with 2 blocks, and which will be distributed on multiple nodes in the cluster. If we use 256 MB as a split size to process the data, and to process the data using one mapper, one of the splits have to be copied to another node, so the performance might go down. And also, even in the larger files, if you want to process a lot quicker, you should consider reducing the split size even less than 128 MB. So you need to understand the side effects in both ways, and then you should be able to determine when to use which one. Okay. So in this case, this will be definitely more efficient. It might not be faster. Faster does not mean efficient. Efficient means it uses much lesser resources compared to split size of 128 MB, because it need not actually fork as many mappers as we have done with 128 MB split size. Okay, for each of these techniques, you have to understand the side effects of it, and then you have to come up with that. And that is one thing, and I will cover one more thing before we close today. The other thing is getting the number of mappers correct. Okay. In this case, it is creating, it is sorting data using 7 mappers. Okay. It's just a count, so there is not much data in each of these files. But even in this, if you see, one file have 4 times of data than other files. These 5 files have only 11 bytes of data, whereas these two have 22 bytes of data, and this one have 45 bytes of data. So there is a skew in the size of the files. So to understand the reason behind the skew, first you need to understand how many number of reducers are used. So yeah, there are 8 files here. So there are eight reducers. So I think MapReduce framework itself has figured out the 8 reducers, and it used 8 reducers. Between mapper and reduce, let me go back here. And let me open this one. Yeah, not this one. Okay, let me do a new thing. So we have a 2 GB file. So we have a 2 GB file, and we have a cluster. Okay, and we have map, and we have reducer. All mappers and reducers both run in the same cluster. Okay, so this is our cluster. No need to worry much about the cluster now. But between the mapper and reducer, there is a sub and sort phase. So this can be n number of mappers, and there can be n number of reducers. Okay. As part of sub and sort phase, depending upon the keys that are emitted out of the mapper. In this case, we have 13 keys because there are 13 pips in the cards. There are 13 keys. Okay. And depending upon the number of reducers, as part of the internal algorithm, it has determined 8 reducers to process this data. So depending upon the number of reducers, for each value, we have 2, we have 3, we have 4, we have 5, 6, so on, up to A in the deck of cards. Okay. So our number of reducers is 8. Okay. So the algorithm works like this. On this pip value, it will compute hash. So there will be hash of 2. Hash values are typically numeric. And then there will be mod function applied on this. And then it will be divided by 8. And the remainder will be computed. So in this case, let's say hash of 2 is 2 itself. So 2 mod 8 is 2. Yeah, 2 mod 8 is 2. 3 mod 8 is 3. 4 mod 8 is 4, etc. And then JQK, depending upon its hash value, it can be 2, it can be 3, it can be 4, or anything. We don't know. We don't know internally. But if you understand the what is happening behind the scenes is, depending upon the number of reducers, it will compute the hash value on each of the keys that are entered out of the mapper. In this case, keys are pips, and the framework will compute the hash value and divide by 8, and it will store, using the remainder, it will pass the value to the corresponding reducer. So all the values which give remainder 2 will go to one reducer. All the hash values which give remainder 3 will go to another reducer. Like that it will work. So in this case, as we have seen, the first one have 10, 9, A, and Q because it has 4 times the values. I am assuming that the first one have these 4. Okay, let us see that. Yeah, these 4 are in this. The reason the hash value of these 4 values is same, and the mod when the hash value of these 4 values are divided by 8, the remainder is 0. So all those records have gone to the same reducer. Whereas for other ones, it is not the case. For other ones, the hash values are different, and depending upon the hash value, it has gone to its own reducer. So one of the things you can understand by seeing the properties of this file is that there is a skew. So the skew in the sense one file is so one of the reducers is processing a lot more data than the other reducers. So in this case, the first reducer have processed a lot more than 4 times of 3, 4, 5, 6, and 7, and 1 and 2 have processed 2 times of this. So there is a skew. So to address this skew, you can actually play with the reducers. So let's say instead of 8 reducers, we want to specify 4. Okay. So you can give -d map reduce tasks and equal to 4. By default, it is taking 8. Now let us see what will happen by specifying it as 4. I have to give the new path. So no need to wait until it goes to the reduce phase. We can immediately troubleshoot by going to this path, because number of reducers are predetermined before the job is submitted, either by passing a runtime or by configuring it in the program. It is still using 8, so the parameter is incorrect. Let me see. Go. Map reduce. Let me see. Yeah, this is the one. So the parameter is incorrect. I can. So I will document these things, and step by step, I will also copy the data. I will put the jar file in appropriate location in our cluster on host 07. You can run these things, and you can figure out, go through the counters and try to see the difference, and it will be pretty self-explanatory to you. Okay. So now let us see what is going on. This is the path, so this is the link. Okay, and here you can see it is now using 4 reduce. So while running this, if you are curious about these things, if you have some development background and if you are curious about these things, you can go to my YouTube channel and click on my channel. Sorry, you can search for Technology Mentor and go to here. You can. I will highly recommend you to subscribe to this. and if you click on playlist, okay, there is a playlist for performance tuning Hadoop MapReduce. Okay, you can click on this, and there are almost all the important stuff related to performance tuning. You can go through this, and you can actually learn quite a bit from performance tuning context. And this playlist is very important for both developers and admins. In my past 10 years of experience, this is one of the areas which is very political, and everyone try to put the blame on others, whereas working collaboratively and try to resolve the issues. So if both developers and admins have the knowledge on performance tuning, then most of the issues can be sorted out more in amicable fashion. Okay, so go to my channel. This channel will be a one-stop shop for almost all the latest and greatest technologies, and I'm planning to add more and more playlists like this. So subscribe to it, and if you are interested, you can actually go through it and learn a lot more about performance tuning. And most of these things will not be covered as part of the course. Okay, I think now it might have ran already. Now let us see the output. And you can actually practice those things, whatever I have. So now you can see there are only 4 files. Still, it is not equally distributed. The reason is still there is a queue. In this case, what you have to do is you have to talk to developers and ask them to come up with a custom partitioner where data can be equally distributed. And this is very significant. It is very significant to understand the role of number of reducers in that, and the side effect of skew while determining the number of reducers. And as if you are from development background, you should be aware of how to address that programmatically. So you can customize the partitioners by leveraging framework APIs, MapReduce framework APIs, and you can make sure that you get data equally distributed to all the reducers for most of the use cases. Okay, so that is it for today. So far we have covered MapReduce core components. Go through it. They are pretty vast. Unless you practice and you come back to me with questions, I will not be able to cover all the aspects of it. The main intention of the course is to create the flow to build the cluster and identify all the pain points while building the cluster. So far, we have installed Cloudera Manager, and then we have installed Cloudera distribution of Hadoop on almost 14 nodes. There are 2 nodes which have failed. We will troubleshoot in the next class. And then we have configured the HDFS Zookeeper. We have configured HDFS. We have configured high availability on HDFS. And then we have seen both MapReduce Classic, how to set it up, and also we have seen how to set up Yarn, and also we have seen how to run the jobs and how to collaborate with developers. Briefly, we have also seen briefly how to collaborate with developers and schedule jobs and troubleshoot the issues using MapReduce to execute the MapReduce applications. In the next class, we will try to set up Hive. So we are going a little bit higher level. Core components are done. Using the same approach, we will try to understand the architecture of Hive, set up the Hive, and also know all the important details about Hive from the perspective of the administrator. Okay, I'm stopping the recording for now, and I will wait for 2 more minutes. If you have any questions, I will address them.